Here we have the acceleration versus time graph for an object moving in one dimension. We're told that the graph has a scale of 12 meters per second squared, which is this A as the top part. So that means that we have, so with 6 tick marks, we have 2 meters per second squared per tick mark. Time is in seconds, so we see each tick mark counts as 1 second. We're interested in what the particle's velocity is when it feels this much acceleration. What we see here is that the acceleration is changing. It's not a constant value, but the acceleration is mostly positive. So if the particle starts with a positive velocity and has mostly a positive acceleration, it's going to be going faster and faster to the right for most of the time. After 4 seconds, the acceleration is negative, and so the object will actually begin to slow down a little bit. But we can imagine with how much time the particle has been speeding up, even if it slows a little bit, we're still talking about having a velocity that should be a fair bit bigger than its initial 7 meters per second. And we want to find out what that is at t seconds. Well, if we're given the acceleration graph, we can find velocity by integrating acceleration. When we have an acceleration graph, we can find velocity by finding the area under the curve. So, to find the change in velocity, we will be finding the area under the curve between -2 and 6. Now, one point to make, we are going to distinguish here because the area in blue is above the axis, and so that is positive area, which tells us a positive change in velocity in that region. Now, when we think typically of area, area always has to be positive. But when we're talking about area in terms of an integration, area beneath the curve actually counts as a negative amount. And so this region will give us a negative change of velocity, because what that's telling us is the acceleration is below the axis, the acceleration is negative, so the object's slowing down, so its change in velocity is negative, is less than it was before. So, if we want to find the velocity, we have to add up the areas under the curve. So looking from t equals -2 until t equals 4 seconds, which is all of the region while the acceleration is positive, we see the shape here is a triangle. And if we want the area under the curve will be the area of a triangle, which is 1/2 base times height. Here, our base goes from -2 to 4. The length of that base then is 6 seconds. When we're looking at the height goes from the axis up to the top, a sub s, which is defined as 12 meters per second. And so that total distance here is 6 tick marks, that's 12 meters per second. When we multiply the two, 1/2 times 6 gives us 3. 3 times 12 gives us a total area of 36 meters per second. And that is the change in velocity in that time frame. So what that's telling us then is that if we were initially going at 7 meters per second at the very beginning, and then we have positive acceleration all of this time, that will add on another 36 meters per second, so that by the time we reach 4 seconds, the velocity should be 43 meters per second, because we started off going 7 meters per second and we went 36 meters per second faster due to that acceleration. However, we're not done yet. We want the velocity all the way to t equals 6 seconds, and so we have to look at this remaining part. we see from the shape it's still a triangle, so to do the integral, to add up the area under the curve, we are still looking at a triangle. And so the area here is again 1/2 base times height. Here the base is 2 seconds because we're going from 4 seconds to 6 seconds. Our height is going to be a negative. It's negative 2 tick marks. That's negative 4 meters per second. We said that the total scale is 12 for 6 tick marks, so each tick mark represents 2 meters per second. These 2 tick marks together represent 4 meters per second, and it's negative because it's beneath the axis. What that means here, the 2 and the 1/2 cancel, and our area is a negative 4 meters per second. And that is the change of velocity in that case. That is how much the velocity has decreased, actually, because the acceleration is negative. We're slowing down. So what that means is we were at 43 meters per second, we slow down by 4 meters per second, and that gives us a velocity at time t equals 6 to be 39 meters per second. Generally, what you would do in this situation is you would add up all the area altogether. You'd have the 36 meters per second of increased velocity plus the negative 4 meters per second of decreased velocity. You'd combine those together and then add to the initial velocity. But in this case, we split it up into 2 parts to show step by step what was happening.